talk about in the general area of configuration management and service enablement in the software-defined environment. So typically configurations management is kind of like a sysadmin. Is kind of always frowned upon, or is kind of a black art. Like, do this, you have something not working, you just figure something out, go and figure kind of thing. But with the cloud, what has happened is that the systems are so complex and so dynamic. It's not that you just figure out one time and you're done. So for example, you take Netflix as an example. So at any point in time, there are 10,000 servers actually which is on Amazon. Netflix no more is just a company, it actually is an application, right? Running on Amazon. So it has 10,000 plus servers at any point in time dynamically getting provisioned. And it's not just the provision, they actually configured, tuned so that you can watch movies seamlessly streamed to your house. So this is a very agile infrastructure. It's actually coming and going. It dynamically, being spawned. So there's no time to just, figure it out and fix it. It has to be part of the whole infrastructure management planning. So the development and operations are no more two separate things. So this actually has become, cloud has accelerated this into more of this technology into more of a science in practice. No more is a kind of a black. So there are a lot of activities in this area. So I'm actually trying to summarize. I have a lot of slides. So I'm going to actually touch upon the main themes, but I'm going to leave the slides for the conference. So this is actually joint work with my collaborators. My colleague Salman Bassett from IBM Research and Professor Theo Benson from Duke University. So here's a brief motivation. Cloud right now transition. The first wave of cloud happened where likes of Amazon, Rackspace, Microsoft and others try to create this on-demand elastic infrastructure. The whole theme was to actually reduce this capex. Basically, you don't manage infrastructure, you basically have this on-demand resource. That used to be the first generation. Focus actually was that companies, it provides a virtualized infrastructure, you get as when you want, and that's what used to be done. But now basically, okay, now you have infrastructure. What do you do with that? Now to build some application. Now the fun part, okay, you can get it, but you do something. Then you mature the next step. The next phase, what has happened is that, okay, now I want to make it useful. Right? So I want to not just get it, but I want to get it and leave it, get it and release it and build my enterprise applications. For example, Netflix, when they built this application, they found that Amazon actually was not ready. So when Netflix and Amazon worked, they actually worked together hand in hand. And if you look at Netflix, there's Netflix OSS, the huge set of services got built. They built a lot of nice services, features to actually build huge such services. Okay. So now what happened that next wave you have seen DevOps and agility, enablement. These are the kind of things we are saying. So everything has become a software-defined X, like software-defined networks, software storage, all these things. So what are we talking about here? So we are actually now looking at infrastructure as a software. Okay? So we are thinking the abstraction of infrastructure as a software abstraction. Once you think that this is software abstraction, then it's a programmable. So this is something that I'm going to touch upon to show you what are the progresses been happening in the industry as in academia in this space. So there are three parts to it. So I want to confess, this is something that we presented as a big tutorial, 3.5 hours. So I'm going to squeeze that into 40 minutes, so we won't do it justice. So I'll skip the detailed part, but I'll focus on the main key points. The first part actually is cloud configuration management. So what's happening in that space? Second part is that cloud platform enablement. Okay, so first actually I look at OpenStack part, and then I give an example of what's happening in the Amazon equivalent of that. Third part actually is the software-defined network. What's happening in that space to actually make the network more configurable. So this is actually a very key. Why network? Because that is once you figure out the storage and compute part, the most fragile or most actually not creative, most actually challenging part actually is the network part, because that is something actually is not as easily replicable. Every environment actually has its own varieties. So quickly to give a basic background, just so that level context, what's the on-demand resource, right? You go to Amazon page, you have seen these screens many times, so if you have used Amazon resources, you go there, your lunch instance, click that famous button, Then it gives you basically, okay, choose a operating system stack, like choose a virtual image, right? This equivalent. You basically go and choose, okay, I Linux stack with Ruby and Rails, and Tomcat and all this. Then you go, okay, you know what? Once I have software, I need my size. I need a small, with one CPU, this much memory, and so on. Once you have that, then you specify your keys, like security keys, because by default no one can log in, so you have security keys and authentication. Once you have that, then you have everything. Then you have you get bill of, okay. Now it's just like in 1990s, the fancy thing comes. Oh, you can build your laptop. Can you build your own hardware? Yeah, you can. Who came up with that? That. Before that, actually, there's nothing. Everything actually, you go to a store, whatever is built, that's what you buy. But Dell become so famous because you can click on the web, and here goes the order. Then robots start moving the arms, and actually a computer getting formed for you. Exactly something happening here. Now in 2008, right? Already like 6-7 years ago. This is what here the difference is, it's a virtual machine, right? So this we enter from a physical resource to a more kind of software defined resource. That's the benefit we got here. So because of that, these resources actually you can demand and release programmatically, right? So that is the on-demand part I was saying. So what actually happened? So in this philosophy, what's happening is that instead of actually everybody owning this physical infrastructure, like a football-sized field, huge, big field, like where you can have like 100,000 servers, very densely packed, with a lot of switches and storage. Somebody like Amazon or Google or Cisco or Dell, they put them very densely packed. Okay, so and they give some service like this. User goes to a web page and maybe a web service, either programmatically or through a web interface. You request an infrastructure, then now that goes to a cloud manager. Once cloud manager gets that, it basically finds out, okay, here's a request, where to satisfy this. It has a lot of bookkeeping, figures out, okay, maybe server X has the capacity. At that point, basically it goes and gives all the details and gives the details to that physical service hypervisor. So actual work is done at that layer, the hypervisor layer, right? So at that point, it basically clears that, takes all the images, all the details, and does all the network provisioning and gives back the thing. At that point, you get back the machine. So this is how the on-demand resource whole cycle works, right? I just want to keep this in the background. So given that, now let's look at what does it take to actually take this on-demand resource and build your applications on the fly. So what does it take to actually configure that, right? So what are the challenges? So what does it mean? So let's actually look at, so now here, instead of actually, every sysadmin is to actually, if you do this, every company earlier, they want to actually get resource, configure something, deploy an application. You get a machine, right, from Amazon. That's easy, alright, through UI or through simple script. Once you get this machine, maybe you don't need one machine, maybe you need 10 machines, right? One maybe database, make one load balancer, maybe 5 application server. So you cannot, maybe you need it for 1 hour, right? Then you release it after 1 hour. Maybe then you need 100 servers after that. It's very tedious. So people just write their own scripts. But that becomes very error prone. It's not that easy because configuring databases, configuring web servers, all these things you can lead to a lot of errors. And also, why should you do this every time you struggle? So instead, actually here enters Chef and Puppet, right? This is actually the new generation of the tools. So Chef and Puppet, what has happened is a tool that we'll go through quickly. It allows you to actually build, when you develop a tool, it allows you actually also focus on deployment tools. Instead, if you have used, how many of you have used Chef? Okay. Anybody? Alright. So maybe I'll go slow this part. Even if I cover that part, that should be good enough. So what has happened that instead of, here think of this, suppose you need a web server, 2 web servers, 1 load balancer, okay, 2 web servers, and 3 app servers, okay, Tomcat, and on the back end, suppose you want directs. To configure the whole thing, get it ready, it's going to take you how much time? It can easily take you a day, right? Even if you're an expert. So now what is happening is that people are, when they install these things, they can, instead of writing bash shell scripts, they're using this tool called Chef, and they are writing the scripts as called recipes. Okay? So don't ask me why it's called Chef, why it's called recipe, why the NR tool for knife. Somebody actually was hungry when they wrote this. So that is what they have been calling, okay? So Chef, you go to DevOps web page. So this is a tool that allows you to write the configure. Think of this. So when you are configuring this stuff in your environment, you always hard code it, right? You put the IP address, put the host name, put the usernames. But think about it. If you can parameterize them, then that script somebody else could use it, right? So at least if you can do that, if you can actually write the script in a generic way, maybe you can supply in another file, you can put the IP address, right? So you can consume it. That's all it is, but done in a much more systematic way. So doing it for one machine, doing it for 100 machine is different scale. And making it right, also making it not just IP address, but there may be other issues. Maybe there are different VLANs, maybe there are different vSwitches, maybe their switches are different configurations. So that is the tool. So Chef actually provides you a very nice framework to build the scripts so that once you build it, it can be lifted and shifted and reused in other environment. It's a very nice thing. So everybody actually in system management using this thing. So somebody actually built this cookbooks called recipes, and now people use this, reuse this elsewhere. In 5 minutes you can install it. So if you have OpenStack, for example, if you want to install OpenStack from scratch, forget it. Okay? I mean, if you, at the best, you maybe go to DevOps, okay? Single node, okay, you can do that in 10 minutes. If I challenge you 2 node, you're stuck. It will take you maybe a few hours. I say, okay, can you change this configuration and make it multi-node? If you've never done it can take days, right? So now if I want to actually, your company actually hiring you, it's not a big job. So, I want a 10 node OpenStack ready in 2 hours. Can you do it? So it's an impossible task if you have not done it. Even if you have done it, it's very difficult because a lot of parameters, tons of, I'll show you a little later, the tons of parameters you have to take care of that. Networking, at least networking storage part is not simple. So there are already experts who have released this Chef recipes that you can take it and customize it, and if you know how it works, then it's a matter of a few, maybe if not days, few hours. Once you figure out the parameters, local environment, basically you have to localize to local environment. So once you know the parameters, it's all about basically deploying the scripts. Okay? So this is what I'm trying to tell you is that these are some more toolings, advancements that happened that has made this system configuration as more of a kind of a technology than a black art. Okay? Because sometimes what happens, you just do something, it works, but after 2-3 days it breaks. So that's how does it verify, test, deploy, and verify. That's basically what it's trying to do. Okay. Now let's look at what it is. So here are the traditional phases, right? Produce, deploy, operate, operate. So these are the kind of the life cycle of a typical software cycle, right? You produce it, deploy it, operate, and that's it. So what used to happen, and also typically you want zero customer downtime. That's actually a requirement, and also you want no SLAs to be violated. That's also you want, right? So how do you do this? So traditionally, what has happened is the following: produce software. Okay, traditionally write code, perform simple verification test, perform functional test, integrate code, perform test, release alpha, release beta, release this, release that, right? So how long does it take? If you used to see IBM cycle or Microsoft cycle, the release feature cycle is to 18 months. Okay, 18 months. If you have a new feature, that used to be thing. 18 because you should go to regression test, development, testing, alpha, beta, release. Do you know how many times? What's the release cycle of Facebook? The Facebook that you're using every day, right? How many of you use Facebook? I think that's no question to be asked, right? All right. So, do you know the features, right? The Facebook just released a new feature called chat, right? Have you guys tried it? I don't know if you have tried it, but they just released a feature chat. They push updates to they put updates. Do you know how many updates they release? So every feature in like Facebook kind of application is very complex. It's a very complex software. Like at least 100 people work on a simple project. A reasonable project, 100 people work. It's a pretty lot of teaming effort. So it's a pretty complex thing. So how many times do you think? What is life cycle of a Facebook release? What does release means? They develop it, they test it, right? I mean, they do this thing, they then test in the development environment, test in the real environment, then deploy it, the whole cycle. How many times Facebook does it every day or every month? Any idea? Any guess? 2 per day. Okay, at least 2 per day. So how can you do a whole thing? So it's a very complex process, right? How if it has to be completely automated? It's not just enough. It's not just enough to actually build the software. It has to be done in such a way, because this whole thing has to be so means that it has to be part of the development process. It cannot be a separate process. Okay, so the whole thing has shifted, right? So it's too slow. It doesn't work anymore. So release cycle actually has shrunk dramatically. So if you are looking for a kind of a good technology role or a developer role, the first question you ask gets tested. And Facebook and Google kind of LinkedIn kind of Twitter interviews is that if first get drilled on the DevOps, you say what the hell is happening? Why this guy is asking these questions? Because that is the first thing they want to know. Are you comfortable actually working with other people's 20 other people's and be able to whatever you have actually written do you know actually it's not going to make it worse? Forget about making it better. Can you make it worse? Can you guarantee that it's not going to make the feature better? So that is you have to take it all the way. Okay, it's not just sufficient. Just coding is not enough anymore. So and also that to make it more complex, you are actually working on top of a what? You are working on top of a dynamic infrastructure. It's just basically it's just equivalent to changing tire of a running car. Is that analogy clear? Because no more servers are constant anymore. Servers are coming and going. Networks are changing. IPs are changing. So that's the problem. So what are tools in terms of produce? So actually Git is one of the Git, Jenkins or Gerrit. These are the kind of the tools people traditionally use these days. So Git actually is an amazing tool if you have used it. So it actually gives you a kind of a in parallel. So compared to SVN or CVS, so this actually gives you a kind of a completely a in parallel checkout. You check out, you have your own server. It's a kind of completely decentralized coding. Okay, unlike SVN where actually you check out, you have one centralized repository, right? But here actually everybody has their own copy. Everybody has their own server. That's why actually is one of the main things. So we'll see that actually how that framework fits into this kind of DevOps part. Okay. All right. So I'm not going to go much into that. So let's actually look at our deploy cycle. So why this model doesn't work well in the era of cloud, traditional way of getting dividends and that? Because OpenStack actually has the controller itself actually has at least 5 to 7 nodes depending on what scale you're looking at. Right? If you have 100 compute nodes, you need at least 5 to 7 nodes. You have distribute different controllers to actually do that. Right? So you have at least 40 configuration files. How do you actually possibly can manage to actually do that in that kind of things? So I told you an example. Netflix is deployed more than 10,000 machines. Their management stack and all this. So you cannot actually do that deployed manually, right? So there is actually a big chasm between the developers and the operators. People who are developing the code, I think there is actually a big gap. So the gap actually, the huge divide, that gap has to join. Okay, that's the point I was trying to make. So how do you do that? The whole point right now is that treat the infrastructure as a code. So you make your infrastructure as a programmable entity. So that is when you hear software defined X, so people actually are in some sense defining that. So basically treating software defined network, storage or compute, they're actually giving you an abstraction, they're increasing layer abstraction, allowing that infrastructure to be treated as a code. Then you can actually configure it. Is that clear? When that is the point that is the abstraction that actually they're trying to do. So what are the tools challenges? There are quite a bit of tools in the operational tools. Let me actually go quickly into this actually we have already made. So let's actually look at the process. Okay. So typically this is the DevOps process. What happens that you understand the code and configure changes, you make a new release, right? So if I quickly look at the cycle, you look at the new code, participant development, and make a new release. Right, and you basically can come and if you have a new target, you basically put the dependencies because the code that you develop may have dependency. You push that to orchestration engine, and maybe the software now ready. You compile the code, you have a new software, and you now have deployed an engine. Through the orchestration, you push that in target environment. Okay? This is the traditional cycle. So it's not complex. It's kind of a out of the just traditional book. Okay. So if you have, so this is this. If any code changes, this whole thing has to start all over again, right? If code change comes here, same code actually has to take the target details and deploy, and deployment engine has to push it here. So now how this is being done here? So in terms of deployment, you can't do manually. How to deploy? So Fluid interface is code. Okay. So you can develop your own code, on deployment code, or you can use something like Chef or Puppet. Okay. So what we are going to focus here is, so this is the, so what a framework like Chef or Puppet has done is that, so they actually have made this life easier. So this coding and this has been done by Git. Okay, so that actually all organization is done seamlessly. You have to manage it. But orchestration engine is your this you cannot do anything, because this is dependency of your own software or environment, meaning the what's your IP addresses, how many LANs are here, what are the network addresses permissible here. Those are your environment specifics. No one can help with that. So that actually you have to get that, right? No problem. So that you feed into your engine, orchestration engine or script, bigger script, right? But this is where you don't want to actually install scripts. Okay, here is, now I figured out all my parameters, I figured out my install software. I want to install my database with this dependency. That part you don't want to redo it again, because somebody has done it. If somebody has figured out dependency, somebody knows how to install MySQL, why do you want to figure out how to install MySQL, right? So this is the part that actually can be automated using Chef. Okay? So that's basically the part. So if I had to do that, challenge is automation is that how do I know that automatic deployment worked? How do I know that configurations are correct? So there are two main questions I need to know, right? So here enters the Chef. So Chef basically, this is the framework. What is Chef? Chef is nothing but a configuration management deployment tool. It's written in Ruby and Erlang. Okay. So the earlier version actually was in Puppet, and the owner of Puppet basically formed this company. They basically use Chef. Right? So Chef actually has a server where actually all these recipes are stored. Once this is there, workstation is basically is your laptop basically where you're making your changes, and this is node is where target node you're pushing. This is a node where you're installing stuff. That's the three things basically. Your server where all cookbooks are. Here you make your changes, you push it there, and once you have that, then you push the target node. Okay, and of course these are static entities. Like here your cookbooks. Okay, cookbooks are nothing but recipes. Cookbooks nothing but scripts. You can think of, right? All right. So, okay. So in this whole framework, as I said, where does Chef come into picture? This is your DevOps stack. This is your DevOps framework. Chef basically is helping you with this. So this is actually helping you automate this deployment and verification part, because somebody actually has released this script or this in terms of the framework in system independent platform environment independent installation scripts. Okay, so somebody has written that here. Then you take that, you figure out what is your specifications are, and you push that to your orchestration engine. So this is how the framework is. Okay. All right. Is there any questions so far on this? All right. So I know it's if you're not done it, then it's too many information. But once you do it one time, then actually it's easy. So okay. So I'm going to skip a few slides. I'm not going to go details of what recipe construct, but quickly, Chef basically here comes a cookbook. Each cookbook is nothing but a bunch of recipes. A recipe is nothing but, you can think of as a big bunch of classes in Java language, and each recipe is a class. Okay, and each recipe actually is a little different. Each recipe basically has a role, meaning that role is a very specific functionality. Okay, install my MySQL, install this web server. These are kind of different roles. Okay, so this is basically okay. And recipe can deploy according to environment, meaning that you can choose an environment. So environment is where you are encapsulating your specific details of you capturing your differences from your environment to my environment. For one environment may be Red Hat, and then Ubuntu, So this is where actually you are abstracting out the details. Is that clear? Environment allows you to actually make it specific to your specific details. Okay, so I'm not. So these are the different parts of the cookbook. I'm not attributes, recipe, definitions, resources. I'm not going to go into that. Okay, I'm just going to skip this. But I have details of that. Also, I have a detailed example of a cookbook, so you can actually look at this in your own time. So okay, so I'm not going to go into. So this actually a quick example of what is a DevOps cycle, how Chef has been now used to automate the main pain point, so that the generics are separated from specifics. So you discover your specifics and use that specifics to take 90% of work. 90% of work actually are automated. Use that using the Chef framework, right? Okay. So now let's look at how Amazon does that. Amazon actually uses the same framework. So Amazon actually adopted exactly the same framework. So if you have Amazon resources, like you have databases like DynamoDB, RDS, SNS, SQS, name it. Amazon actually has, I don't know how many, 20 plus services besides just giving a server. Like the example I gave you, just getting a server, right? What do you get a server? Nothing. Just maybe 10 servers, maybe Elastic servers, meaning that if my workload changes, I need 10 servers. If my workload decreases, I only need 5 servers. The whole thing automation part, right? So this whole deployment, all this deployment of Amazon artifacts are done through something called Amazon OpsWork. Amazon OpsWork is nothing but, it basically uses the Chef Cookbook. Okay? It's basically, once you know the cookbook, Chef Cookbook, basically Amazon allows you a just same framework using Chef. So they have something called stack, layer, instances, and apps. Stack is basically a set of infrastructures. A layer is within that layer. And within layer, a layer consists of a set of instances. Instance is nothing but registers. Okay? So this is the I just wanted to show you how Amazon actually has built the same exact framework. For example, if you have 10 servers, okay, 10 server is your 10 servers stacked up like this, okay. That's you have 10 layers in each server. So we have an app server, okay. In the app server consists of a big Amazon instance. In the big Amazon instance, suppose big VM virtual machine, right? In the big virtual machine, suppose you have a web server, right? So this is the framework. So you have this stack. In the stack, you have 3 layers: web server, app server, and database server. In that, you have instance. Is that clear? So once you have that, then that interaction is actually captured using this offshore framework. So these are the framework they have. Exact same thing again. So setup is set to an instance. Whenever you want to actually create a setup, you set that trigger to the instance. Anyway, so I just want to quickly draw the analogy. Just like a Chef in the community, what people are using it. Similarly, Amazon actually adopted the exact same similar framework. That's called OpsWork, and that is how you can use to actually automate the Amazon infrastructure configurations. Okay, so this is one example of, suppose if you want to have such a large infrastructure, you have a bunch of Apache, it's a PHP app servers, MySQL, and that actually load balancer using actually load balancer. You don't manually configure this. If you want to manually configure this, it's going to take you quite some time. So Amazon used to have something called cloud formation or Elastic Beanstalk. Cloud formation used to be actually a set of servers that actually you configure together in this fashion. But that also but this is something that is much easier, because once you write this is a template. Okay, it's a kind of template. You have a template. Once you write a template as a cookbook, then you can use the Amazon OpsWork framework to actually push it to have this. So what happens that is, once you push this using the OpsWork, it goes and creates virtual machine 1, 2, 3, 4, 5, 6, 7, then pushes the images, and after it pushes the images, then actually runs the network, all the auto scripts then kicks in. Okay? Is that clear? Okay. I know it will be more clearer if I had to actually do a lab, so that's the part you should do. Okay, so now just to take a quick recap what we did. So we just looked at the challenges on the agile infrastructure like cloud. If you want to actually have enable some applications, you need to actually integrate the development cycle with the deployment cycle, and that towards that the infrastructure actually is taken as a code, abstraction as a code, and DevOps actually is enabled some tooling like Shape and Cookbook. So now let's look at cloud enablement platform. So now that you have cloud, what are the services? What are the things that are being done to make it simpler, so that actually you can actually deploy applications, use them, and use them easily. Okay. So I have two things I have. I don't know how much time I have. I'll stop whenever you tell me. So
20 minutes.
20 minutes?
Yes.
Okay. So the first part actually I look at is the OpenStack. So OpenStack actually is in a stage where Linux used to be in 1990, right? So when in 1990, when actually if you born, some of you, many of you probably, okay. So if you have installed Linux in that time, 1995, that time, it used to be a great feat, right? So installing Linux was not easy. So it takes hours, finally days, and you can make it work everything. Maybe then sound card doesn't work, and because wait for discussion, because the driver is the manufacturer doesn't have the driver, so wait for that, okay? Or maybe everything works, but the external doesn't work, the video card doesn't work. It used to be like very, very difficult, right? Then Red Hat came. It made it really, really simple. So what used to be the stage, that is how OpenStack is right now, is much, much better. I mean, a year before actually it was worse, but now it's much better. So taking the OpenStack and building a cloud of a 100-node cloud is still not an easy task. It's pretty complex. It's a company like Mirantis. I don't know if you have heard them. So this is exactly what Red Hat used to do for Linux. Companies like Mirantis or CloudScale are doing that for OpenStack. They basically create. How many of you have heard Mirantis? So they are the largest, one of the largest companies that actually their fame to glory or glory to fame is to that they for eBay and PayPal, they basically 10,000 plus servers. They created the big OpenStack cloud for them. Okay, so they actually have basically they used to publish, they used to create and publish. They have their own tools for creating easily digestible. It allows you to create this OpenStack cloud easily. Okay? So now what people have done is that actually has gone a long way. So now people actually have taken the chef tool and created recipes to actually allow you to very consumable cookbook for creating OpenStack cloud. So Dell, for example, Crocow used to be the tool they created in like 3 years back, when actually it's very difficult to install OpenStack. But now it is matured a lot, so people don't use those tools a lot more. These tools actually have now permeated into become Cookbook, more or less, the other way probably. Okay. So let's look at some of them. So let's look at what are the challenges and what is state of the art there, and then we'll look at actually some of the Amazon services for enablement. So I choose both because one is basically you have full control, meaning there's open source cloud. Other is basically you don't have no control, but you just observe. So, alright. So this used to be the open source. Is pretty open cloud. Open source is crowded. So this is the kind of the ecosystem. So each of them actually you can think of as a cloud. So this is like the IaaS cloud stack, the PaaS cloud stack. You can think of this as SaaS cloud stack. This is not by no means this conflict. So OpenStack actually the IaaS cloud stack, right? So we're talking about here. So Netflix OS is actually is a kind of a little bit in between IaaS and PaaS because they built actually a kind of infrastructure automation layer on top of the IaaS. So it's in between IaaS and PaaS. So if you look at, so this is a timeline of if I just put them, the timeline of what you are seeing here. So if you see that OpenStack first release came somewhere around 2010. Since then, rapidly it has evolved. Every 6 months, actually, they have a pretty good release. So now, actually, it's pretty nice. All right. So IaaS and PaaS open source projects trail their commercial counterparts by 2 or 3 years. That's basically one observation. So the commercial version happens first, then the open source version actually trails kind of 2 to 3 years. That actually has been the trend more or less in this community. So for example, Google, for example, came with the GFS things, big data thing. Then Yahoo came, the open source Hadoop, all this thing came 2-3 years later. So that has been the trend more or less. You see following. IS Cloud, Amazon actually released in 2007, and the first big, I mean, of course, Eclipse, other things are there, but a major thing came, OpenStack came 2010. It's kind of 2 to 3 years kind of delay. All right, so this is a kind of licensing. So luckily that many of them actually is Apache license. So this actually is a good news because it allows you a very flexible license. So you can actually take this and modify and add your tools. So this is, luckily as it has become the trend in the open source cloud. So most of the influential tools are actually in Apache license. So it's a good news. So languages, if you look at what is written, is that it used to be Java, C++ earlier, like things like CloudStack, Eclipse, other things were written in C, C++, in Java. But nowadays, if you look at, it has become Ruby, Python, and PHP. So that's actually a big set. For example, the OpenStack is written in Python. Okay, so this is because this is to for more agile, more easier development. People actually quicker agile development. Not means that you do more errors or no, you're not even going to work. No, actually quicker. This thing people have actually somehow adopted the scripting language. Yeah. So OpenStack actually is what is it? It's basically is a open source for developing IS Cloud. First released in 2010, and Python and governance of So where it's being used? So quite a few public cloud are there. This list is not complete. Actually, 6 months old list. Rackspace, the first public and private cloud they built. HP, IBM Smart Cloud, Red Hat Private Cloud. Quite a few clouds, and this list by no means at all complete because a lot of financial industry they don't help, right? So the whole suite of financial industry actually have been building. Besides VMware or other stuff, they also have gone to the OpenStack cloud. Educational list is not complete. Probably I'll refer to Roy to make a comment, so he can give more educate more on that. So this list I just whatever from the others. Okay, OpenStack is not IS Cloud. Just because you have OpenStack, get to grab a lot of code doesn't mean you have IS Cloud. It just gives you a bunch of code, bunch of controllers. You have to then this whole struggle begins, right? Then actually whole specification begins. So provides 60% of the work. Remaining work is configured running to meet your needs. Okay, first you define the specs. So this is the release. Juno is a September 14th. That's the latest release. So every 6 months they have a release. So it's going to come. Yeah. So conceptually, Nova is the. You can think of OpenStack actually a bunch of daemons. Okay. Nova is for the handle the compute. Cinder is for storage. Image services for glance. All the identity management is Keystone. Network is Neutron. This is why all your SDN stuff is here. Dashboard, all this UI service Horizon. Object store, all this S3 equivalent of Amazon is in Swift. Okay, orchestration is Heat. And monitoring and metering, if you look, if the equivalent of Amazon is a CloudWatch, is the Celemeter. So this actually is very new. So these are a bunch of services. They basically give you a bunch of daemon services. Now you have to take them, configure them, and make them all work. They're not actually out of the box. Okay. So these are a bunch of services that you have to take. Of course, they have queues, messaging services. They have a RabbitMQ queue that actually plugs them together. But these are the things that actually you have to configure them, actually make it operational. And how many of them? How many compute nodes you need? Okay, I have now 1,000 nodes. How many network node I need? So this kind of provisioning, you actually have to figure it out. It's not automatically figured out. So if you are building a 100 node cloud, or 1,000 node cloud, or 500 node cloud, 10 node cloud, the answer is extremely different, very, very different. Even the same sizing, suppose you decide 100 node cloud. Depending on what kind of network requirements you have, the configuration is completely radically different. I just want to go to, with the lack of time, I'm just going to quickly shift to the just network side. Okay, just network side. I'll show you how many varieties of options you have to here. Okay. This is just to not scare you, just to impress you. So this is how the components that are linked together. So this is the flow diagram of different network compute. I by no means I am expecting to digest this, but each of them actually I have color coded differently. So actually you can see the flow among themselves, but this is the interaction among each other, different components. Okay. So Nova, the greens actually are pretty mature. The network is the one actually is evolving. Okay. Now monitoring is very new. Not that it's more complex; it's just very new. They kind of say, hey, this is okay, easy. That's not evolved. But this is the part actually. This network part is the where whole action is happening. This is where industry. This is where actually the most advanced stuff. The whole SDN stuff actually is happening, being adopted in OpenStack faster than any other cloud. So this is actually the real map. All right. So I'm just going to leave this one. All right. So this is actually I redo a little more nicer. I took this one it's a black and white. I just color coded it with different color so that you can actually at least attempt to understand differently. Again, once you understand, it's not difficult, but that's not a hard. So what I am trying to say is that let's focus on network part. Okay. Suppose you want to deploy application. You want to actually deploy a management strategy. So what is the choices you need to make? These are a bunch of services. Your cloud controller node. You have a cloud controller node, right? That could be more than one node. So depending on how many node OpenStack you want, that could be one controller node, 2, 10. It depends on size. It depends on the bottleneck, right? How many size. You can actually, it allows you to put everything in one node. It's written that way, you can written node. But you don't scale, right? So these are the bunch of, so it's a MySQL server, RabbitMQ, this is the messaging queue, Nova scheduler, conductor, keynote. So these are a bunch of daemons you can think of. Okay? You need to figure out how many controller node, where you going to put where. Okay? So the first choice you make. Then these are for every compute node, depending on how many servers you have, how many racks of things you're managing. Each of them you have to put a compute node. Right? Now network node. Network node is where you have separate network node. Okay? You put that. And network node, compute node actually all connect to this. And maybe through that you have a connection to the internet, because finally everybody has to log into the VM. VMs are being created here, right? Finally you have to log in here, right? So what are the choices? Choices are the following. So what are the choices in the OpenStack network? So these are the choices, alright? Neutron actually allows you VLAN. You can actually have a full mesh tunnels, you can have flat network. Nova network actually is a little more simpler. You can actually VLAN or you can have flat network. So let's look at, keep this in the mind, this diagram. So Neutron deployment actually has 5 use cases, right? So which one is right for you? So let me actually tell you what is what, right? So they give you 5 options. You can actually, if you deploy it, all the 5 options are there. By default, none of them are on. Now you look at config file, right? So what do you know which one actually, which cloud are you, what am I going to deploy for? So then you have to understand that, right? Okay. Single flat network means this. Alright? Everything actually has a shared network, 30.0.0.0. All the VMs actually in the same this thing. Is that what you want? Maybe this is what all you want, because all the organizations has this. Simple. Okay? Everybody actually has a single NIC. Okay? One single NIC. Done. It's not a bad thing. But does it meet your organization? So that's the decision you have to make. Okay? So typically if you have 10 leads and single organization, this is sufficient. And this also is the most robust. Simplicity, right? Simplicity in the game on them. So this is simple. Done. What is multi-flat network? Maybe you have, this is good, but I have 2 departments. I don't want this department to share that department, I will keep 2 sides separate. Then single flat will not work. You need to actually have multiple NICs. So because you want this tenant to be on 2 these things, right? Suppose you have some tenants which needs to be on 2 different networks, 30.1 network, 30.2 network. Then you need some virtual machine to actually have 2 virtual NIC. Then you cannot actually have a flat network. Then actually you have to go this network, multi-flat network. Is that clear? So I'm basically trying to motivate that even simple choices that you make, network choices, mix the complex, drive the whole thing pretty complex. Maybe mix flat and private network. Maybe that is not enough. You actually want to actually have a private address. That's what actually is necessary, because if you log into Amazon virtual machine, it has a public facing network IP address, has a private network address, right? Two things. Maybe that's actually you need 30-dot network which connects to the router. Maybe you need 10-dot network. Then what do you need? Maybe you need actually a VLAN. Maybe you can set up the same network, but you need two network, 10-dot network and 30-dot network. So then the flat or multi-flat is not going to work. Is that clear? So if you have a single NIC, NIC here and single NIC like this here, you need to actually have a separate configuration like this. How you do that? Okay, then actually you need either a VLAN or a GI tunnel to do this. So that is how actually driving your requirement. Or maybe you need a little more complex like this. You actually have departments, department 2, and have their own things. Maybe you have a computer science, electrical engineering, or maybe different departments. Each of them actually have their own isolations. They don't want to share anything. They actually have their own routers. So this is the things you want. So this is just to give an example. It's not having 10 servers or 20 servers, 30 servers. Okay, it's not just having bunch of nodes and bunch of these things. Very quickly, how you want to deploy applications, that quickly basically tells you what your network requirement is. Based on that, actually, you have to configure your OpenStack. Just to give you an example, this actually is making complex. So, what are you going to do that? Are you going to read the 40 files, configure the files, and do all this thing? It's pretty complex. So instead, you go to the cookbook, okay, get a right cookbook, write roles, and then drive this configurations. That's how people are trying to do that. Okay. All right. So is that clear? Please tell me what time I have. Maybe 10 minutes. Sorry.
5 more minutes.
5 more minutes. All right. Okay. So these are. I'm saying that this is actually a good list of questions. So this is the work of my colleague. So he actually specializes in OpenStack community, and he works in OpenStack and software, all this stuff. So he basically sat down and they basically created this recipe, cookbook, step-based recipe for deploying large-scale OpenStack cloud. So they went through very methodically. So there are top 20 questions you go through to derive write a cookbook, a good cookbook. Okay, so they took the cookbook that have been published from HP, from Cisco, and from other open source community, and they derive their own cookbook here. So these are the kind of the most systematic way to do that. Okay, so I'm just going to leave it here. But these are kind of different storage configuration, network configuration. So this is a very detailed list of stuff we decided to make it public. Okay, so this is work that we have make it open. Okay. So what I'm going to do next in the next 5 minutes, because not enough. So what I'm going to do is that very quickly tell you is that, so this is so far we have done motivated that you have to treat as an infrastructure. So Amazon actually, I'm going to skip the Amazon part. Go to the next. I'm going to go to the next part. Is basically the what is happening to manage the configuration in the SDN. So everybody, I'm assuming many of you actually know network, software-defined network is. So I'm going to quickly, maybe in the first 1 minute, I'll introduce that and then tell you what's happening, what are the configuration challenges happening there. So, because it's not that simple. Just because SDN is there, it's not solving all the problems. There are a lot of problems there too. Okay. So, but this is where actually a lot of work is happening. Okay. So, all right. So traditionally, all right, my colleague, this is my Duke colleague who actually used to be, he's a needle at me, okay, IBM mainframe. I don't know why he puts IBM, he couldn't make it HP mainframe too. But it's CPU, OS and applications. Cisco used to be like that, right? No, Cisco is like that. So equivalent of network, right? ASIC, switch, and so this is kind of a very tight layering, right? So So what's the problem with that? Restricted to ill-defined vendor CLI. So Cisco switches are not that easy to actually configure. They have the very obscure commands. Cisco switches are fabulous. Routers are great. But the command line tools, the way to actually put to the network is very awful. They also admit that. Okay? They put a lot of effort to actually create nice manageable software, but that's the problem. So what has happened is that this is the only slide if you have to take away. This is the only slide I want to take away. So what is HDN? If I have to summarize one way, that there is a clean separation being done here. The low-level fabric, the switch hardware and switch operating system is being separated from network OS and applications. There is a clean boundary here. The nice API is being exposed. So that is being actually exposed very clearly, so that this can be treated as a software entity. Just like software as a code, this is very similar thing. So southbound APIs decouples the switch hardware from the control functions. Okay. So data stuff, very quick data stuff actually happening here, but control plane actually are very nicely isolated from the data. Alright? So switch operating system exposes the switch hardware primitives. Instead of actually bundling them, Cisco does not do that. They tightly couple that, only expose up there. But here, this API is being exposed for third-party vendors. So you can actually build your nice stuff here. So because of that, what has happened is that this has become a programmatic control here, right? So because of that, you can now treat this stuff, each of these switches, each of this fabric, as a kind of a software entity. You can actually now treat them nicely to do that. Okay. All right. So okay. So where do I? Let me see where do I start. So. Let me actually stop here. So, what has happened is that, so instead of actually combining it as a vertical stack, now there has been a separation, so that they very cleanly the upper layer, control layer, has been decoupled from the data layer. So because of that, you have you have opportunity now to treat the lower layer as another layer of abstraction to actually manage that. Okay. So let me go into So this is how it works now. Okay. So what you do is I don't know where to start. Okay. So now a big problem here is that now that you have a separation, now you don't know, your controller has become, so now how many controllers you want? So do you have one? Do you have many? How many controllers you want? How many nodes you want to manage? Given a number of switches, how many number of controllers you want to carry in, right? So if you look at that, okay, alright. So suppose you have 3 switches, maybe one controller is enough. Suppose you have a lot of switches, right? So what is the decision you are going to make? How many switches are you going to make? So divide and conquer, alright? So you basically build, because now that you have the freedom, now have another layer of separation, you can actually treat them as one entity, treat them one entity, and then combine them as separate. Right? So one big decision here choice here is that how many controllers. Alright? So again, SDN, although there one challenge is that no one actually tells you. Just like the OpenStack, I explained to you a lot of configure choices. Here you have a configure choice that you have to make. The decision is how many controllers you want. Right? How do you assign switches to controllers? Which switch should be assigned to which controllers? How do you group them? Right? So now, earlier what used to happen that everything used to be distributed, right, in network. But right now, actually, what's happened that your controller has becoming centralized. So if there's a problem, then actually you have single point of failure. So how do you address that? Okay, that has become another design choice. Okay, become headache. Alright. So security. So earlier, basically, if there is some issue, you have to go and chase all the routers to actually figure what's going on. But right now, because of controller, all the flows, you can actually hack this one and be able to monitor this thing. And you know who is monitoring, right? So this has become another big issue. So these are some of the challenges that you can face. Alright? Okay, so I'm going to actually, instead of actually going too much, I'm just